In this video, I introduce a Parzen window estimation in machine learning. Parzen window estimation predicts the posterior probability distribution from a training dataset instead of from a conditional probability and prior like a maximum likelihood estimate. The probability P that a random variable X falls in a region R is given by integral of probability density function P over R. The idea of a Parzen window estimation is to predict the smooth value of the probability density function by estimating the probability mass function. Given n samples, x1 to xn, according to the binomial law, the probability pk that k of n samples fall in R is defined as this formulation where nk is the number of combinations. The expected value for k is equal to n times p, where n is the number of the total samples and p is the probability of successes. After simple rearrangement, a good estimate for the probability p is written as k divided by n, where k is the number of successes. Suppose that R is very small. The probability density function P doesn't vary within R, defining V as a volume enclosed by R. We use P times V to approximate the integral of probability density function P over R, which gives us probability density function P as k divided by n divided by v. This approximation becomes equality as n tends to infinity. Our goal is to calculate this p by computing this k. Using kn and vn to indicate the answer k and v, we have this kn divided by n divided by vn to approximate this pn. Now the task is to find kn. When n tends to infinity, if vn tends to 0, kn divided by n tends to 0, and kn tends to 0, pn converges to the posterior probability distribution P. To this end, we define Parzen window function phi that satisfies larger equal to 0 and integral over R is equal to 1. The volume of Vn is defined as HND, where D is the number of dimensions of phi and Hn is the window length of the volume Vn. If k of n samples fall within Vn centered at xi, Kn expressed as interpolation of the Parzen window functions phi, where xi is the coordinates of the ith sample. Substituting Kn into Pn, the probability density function Pn becomes the interpolation of the Parzen window functions phi. Pn converges to posterior probability distribution P as n tends to infinity. For example, if we select Gaussian distribution as a kernel function for h is 0.5 or 1.0, we use this Parzen window function phi to predict the posterior probability distribution. For more details, please check with these references. Thank you. Bye.